Hi, I always have a question about F5 container ingress services, the classic BIGIP container controller for Kubernetes. And when it's integrated with Kubernetes Flannel VXLAN network, it does not support pod ARP address auto discovery through the normal ARP request reply mechanism. And so the typical way is after you deploy the BIGIP controller, after you deploy any ingress or config map, then the controller will create a static ARP entry for the pod on the BIGIP. So it's not through ARP request and ARP reply from BIGIP. So I did some tests in the lab, and I found a potential solution, and I listed the step here. And so basically the step one is configure the BIGIP VXLAN profile, flooding type as multipoint. So like if you go to the Cloud Docs, so the F5 Cloud Docs website, it says create the VXLAN profile with port 8472 and a flooding type LAN. And when created the VXLAN tunnel, it says use the VXLAN VNI ID 1. So that's the one of the reasons BIGIP cannot do auto discovery for pod ARP. And so instead, if we change the flooding type to multipoint and change the VXLAN VNI ID to 0, when we ping a pod ARP, when we ping a pod IP, the BIGIP will send the ARP request. So this is step one. BIGIP can send ARP request. So how we make sure the pod can send ARP reply? So on the Kubernetes node, we needed to enable the learning attributes to the flannel VXLAN interface on the Kubernetes node. And the third step, we deploy Kubernetes pod, and this will make Kubernetes create a container network interface bridge. By default, it's named CNI0 on the Kubernetes node. And step 4, we add the VXLAN flannel interface on the Kubernetes node to the container network interface bridge CNI0 as a bridge member. And step 5, we deploy the F5 BIGIP controller or container ingress services to populate the node FDB on BIGIP. Now if we pin the pod from BIGIP, we should get a ping reply, and the BIGIP will send a ARP request. The pod will reply with ARP reply, and the BIGIP got the ARP for the pod IP, and then BIGIP can get a ARP reply or SMP reply for SMP request. So is there any potential problem with this solution? I don't know actually. So we will find out maybe in the future any potential problem with it. So I can show you the lab based on these steps. So let's go to our lab, and so on the BIGIP this is my BIGIP. So this is the tunnel VXLAN profile I configured with a flooding type multipoint. So if we list the VXLAN profile, we have the flooding type configured to multipoint instead of LAN. So the port is still 8472 for UDP. And if we look at the tunnel, the flannel VXLAN tunnel properties, we have the VNI ID defined as 0 instead of 1 from the Cloud Docs documentation, right? And we still have the normal self IP on the VXLAN, right? So this is self IP on the flannel VXLAN. So now it's that's all you needed. That's all you need on the BIGIP. And so on the Kubernetes node, we needed to enable the learning attribute to flannel VXLAN interface. So let's go to the Kubernetes node, flannel in. So this is my Kubernetes node. I already deployed the Kubernetes cluster. So if we list the link, so this is the flannel VXLAN interface. You notice that the flannel, the name is flannel.0. So this number, if you have VNI ID defined as 0, so it will like .0 will be the name. If you have VNI ID as 1, it will be like flannel.1. So for example, I can show you a normal flannel interface. So this is a Rancher K8S cluster, and it used the standard flannel implementation. And as you can see here, this is a flannel.1. That the VNI ID 1 is the default VNI in the flannel implementation. And yeah, if you run this command, it will show you more detail, like the VXLAN ID 1, right? And so by default, it has no learning attributes enabled. No learning attributes. That's the standard flannel implementation. if we go to the Flannel here on my Kubernetes cluster, link show dev. If we show our, because we have show our Flannel interface, VXLAN interface. Notice that the VXLAN ID is 0, and there's no learning attributes here. No learning attributes. And the name is flannel.0. But this is a standard Flannel interface implementation, ID1. It has learning attributes. So how I made this happen? So how I made this happen with VNI 0 and no learning attributes. I did the hack here. So this is I hacked the code. So basically, I just go to modify the VXLAN device.go file in the Flannel source code, and notice here it's hard coded. The learning attributes is hard coded as false when creating the Flannel interface, VXLAN interface. Instead, I changed it to true. Okay. So this is how I deployed the Flannel daemon set. As you noticed here, so two parts. One is for the VNI. You can specify your own VNI ID. The daemon set a YAML file. It has a letconf.json block, and here you can define your define the VNI 0 ID. And so also I needed to pull the container image from my repository instead of from. So this is you normally deploy the Flannel daemon set through the core OS repository. Instead, but I modified it to pull the image from my Docker Hub Flannel implementation, and I tagged the image as VXLAN learning. So this is how I deployed the Flannel, and it creates flannel.0 and with no learning attributes. Okay, so we did that part, and so we did this part, and then now let's deploy a Kubernetes pod, and it create a CNI bridge, CNI 0. Okay, so on the Kubernetes node, this is the container network bridge. By default, it's called CNI 0. If we show the CNI bridge, you notice here the VXLAN Flannel interface is member of the bridge, and there are other two member, which is for the pod. So I already deployed it to be the box pod. So this is to be the box pod for testing. It has IP 142.143, right? So they all belong to the bridge because for the network. Okay, so we have the bridge here created. We added the flannel VXLAN interface to the container bridge, and now we needed to deploy the F5 controller to populate load FTP entry on BIGIP. So let's see. I already deployed the BIGIP controller. Oh no, I haven't. Yeah, so okay. So I'll deploy the BIGIP controller so it can populate